Hey, Mr. Worst here again. I'm curious if I can get rid of my fit. No, okay. We'll just deal with it. Okay, so this next section, sorry, is about interpreting distance time graphs in terms of their slope. Now, some of you are like, how do we calculate slope? Blah, blah, blah. This question isn't getting at how do you calculate slope. We just want to look at qualitatively, is the line going up, going down, or is it flat? Those are the questions you're going to be shown three graphs. One's going down, one's going up, and one is flat. And you're going to need to say whether or not that's constant positive velocity, a stopped item, or a constant negative velocity. So I'm going to go over the notes here to show you kind of where you could get at this information, go over that idea, okay? So I'm not going to answer the question like directly for you, but I'm going to give you the knowledge that you need in order to answer the question. Okay, so access your resources here, and this video is one of your resources. Okay, so distance time graphs. So the steeper the line, the more distance per time. It's faster. So here we have a steeper graph. This green one, if you can see that, I can't zoom in. Why can't I zoom in? Mr. Worst, you're making it worse. I can't zoom in. Okay, so this green line here is steeper. So this green line's going faster than the red line. This red line is less steep. It's lower, slower. So the less distance per time. So there's less distance being covered. And so in 2 hours here, the green line, that object only went 20 kilometers, which is actually really far. And then the green line went 40 kilometers in that same unit of time, 2 hours of time. Red went 20, green went 40. It went twice as far. I guess it's far if you're like walking, but if you're like in Star Trek going light speed, it's not very far, 20 kilometers. Okay, never mind. All right. Next item, okay? And this question isn't going to ask you about that, but it's good to know, okay? If distance is increasing, okay, so if the graph is going up, that means the object is moving away from home, moving away from the reference point. And the reference point, the place in distance is 0 here. It is represented by this whole baseline here, okay? So 0 kilometers is all down here. So you see, we are moving away from 0 kilometers. In contrast, if you look over here at this next graph, this line shows an object moving toward 0 kilometers. So this is negative velocity, okay? Is the line going, wait, which way am I going to be in your video? I think I'm going to be this way. A line going down toward the reference point down here at the bottom. A line going down is negative velocity. A line going away from it or up is positive velocity. Okay, so here we have negative velocity with line going down and positive velocity with a line going up. Hope that's helpful. Good luck.